Hello and welcome to G Fun Facts Online, your go-to spot for mind-blowing science. Today, we're diving deep into a tiny world with huge potential, a world that could change how we create medicines, produce clean energy, and so much more. We're talking about superpowered atoms and a surprising helper, magnets. First up, let's talk about something called single atom catalysts, or SACs for short. Imagine you're trying to build something incredibly complex, and you have these super valuable, super effective workers. Traditional methods are like having most of these workers just standing around inside a building not doing much. But with SACs, it's like every single worker is on the front line doing their job perfectly. Scientists take precious metals, like platinum or gold, and spread them out atom by atom on a supportive surface. This means almost 100% of these valuable atoms are actively working to speed up chemical reactions. It's incredibly efficient. Plus, because these atomic workers are all identical and perfectly placed, they can be super selective, making exactly the chemicals we want without a lot of messy byproducts. This is a game changer for things like converting solar energy or creating new drugs. Now hold on to your hats, because we're adding another ingredient, magnetism. We all know magnets stick to fridges, but did you know they can actually influence chemical reactions? It's a field called spin catalysis. Electrons, the tiny particles in atoms, have a property called spin. Think of it like a tiny compass needle. For many chemical reactions to happen, these electron spins might need to flip or change. If this flip is difficult, the reaction slows down. That's where magnets come in. Magnetic fields can talk to these electron spins. They can help align them, make it easier for them to flip, a process called intersystem crossing, or even influence how pairs of reactive molecules behave. It's like giving the reaction a helpful nudge to overcome a tricky step. So what happens when you combine these ultra-efficient single-atom catalysts with the guiding hand of a magnetic field? You get a dynamic duo ready to supercharge chemistry. If the single atoms in our catalyst are magnetic, think iron, cobalt, or nickel, or if they're sitting on a magnetic surface, an external magnetic field can work wonders. Scientists have found some amazing ways this team-up boosts reactions. For example, researchers at Tohoku University showed that a magnetic field could essentially flip a switch in ruthenium single atoms, changing their spin state. This made them way better at grabbing onto nitrate molecules and converting them into ammonia, a vital process for making fertilizer sustainably. Imagine cleaner ways to grow food, thanks to magnets and single atoms. In another cool study, an alternating magnetic field made cobalt single atoms vibrate and heat up ever so slightly, right where the chemical reaction was happening. This atomic magnetic heating dramatically helped in producing oxygen from water, which is key for creating hydrogen fuel. Magnetic fields can also stir the pot at a microscopic level, ensuring reactants get to the catalyst and products get whisked away faster. It's like having tiny magnetic spoons, speeding everything up. And the breakthroughs are already piling up. We've seen magnetic fields dramatically boost the oxygen evolution reaction. In one case with a nickel SAC, activity shot up by a staggering 2,880% under a mild magnetic field. That's not a typo. It's also helping convert harmful CO2 into useful chemicals, making the process of splitting water for hydrogen fuel more efficient, and even improving the performance of new types of batteries, like aqueous zinc-sulfur batteries, by helping iron single atoms do their job better. Of course, this is cutting-edge science, and there are still challenges. Scientists are working hard to understand exactly how these magnetic effects work in different systems. They're trying to design even better magnetic single-atom catalysts and figure out how to use these discoveries on a large industrial scale. Making sure these tiny catalysts are stable and last a long time is also super important. And they need super sophisticated tools to watch these atoms and their spins in action, especially when magnetic fields are involved. But the future for magnetically boosted single-atom catalysis is incredibly bright. Imagine tweaking chemical reactions with pinpoint precision, atom by atom, spin by spin. We could discover new catalysts for all sorts of reactions, maybe even combine magnetic fields with light or electricity for even more control. This isn't just about making things a little better. It's about a giant leap towards a future where chemical processes are far more efficient, selective, and sustainable. So, next time you see a magnet, remember, it's not just a fun toy. It might hold the key to solving some of the world's biggest challenges, one atom at a time. Thanks for tuning into G Fun Facts Online. Don't forget to subscribe for more amazing science stories. Until next time, stay curious.